All right, in the last video, we saw how we could use a transistor, specifically this TIP120 transistor, to act as a throttle on a big motor. And we're going to now include that in our robot design, so it's controlling the speed of the motors on our RC car. The point where our circuit is at right now in the car looks like this. We just have the power supply and motors from the car connected to the relay module. And then the Arduino is opening and closing those relays to kind of do some fixed routine. And when it opens these relays, it just makes the motors go at full speed or zero speed. So we want to modify that so it looks more like this here, where we've included a TIP transistor at the bottom of this. The way that I have this wired right now is kind of similar to what we practiced, but that's a little confusing to look at without a breadboard, which is what we're going to actually use to connect this. So I changed the layout slightly in this view. We still have the two motors from the car, a power supply, relay module, and Arduino. Nothing changed there. The big difference is when it comes to this wire leaving the relay, which is our ground wire that would go back to the battery. Before it goes back, it has to pass through this transistor to get back to the battery supply. And we can open and close how much this transistor is with this extra pin that goes over to pin 3 on our Arduino, just like we saw in the last video. So to make this a reality, let's go ahead and take our car we've been working on and identify which wires we're going to need to disconnect and where we're going to add in our new throttle. The power supply for my car here was the red and black, and my black was the ground, and that's going into this normally closed pin there. So all the motors, after they've got their voltage from the battery pack, that current comes into the relay and then all goes back on this black wire to the battery. We're going to make this go through our transistor first before it can get to the battery. So I need to pop this out of the relay module. All right, and I'm going to add in a new jumper wire there so we can connect it to our transistor easily. All right, so essentially I've just kind of like split that black wire now, right? If I just touch these together, it would be exactly the same circuit, but now I can put something in between here. We used kind of a half-sized breadboard in the last video. Here I'm using one even smaller, a mini-sized breadboard. It doesn't have the power buses on the side and has fewer rows. It's kind of nice for these tiny builds. I'm going to take that wire coming from the relay and put it into one of the rows here. Which row? Well, I guess that's going to be determined by where we put our TIP transistor, right? So current coming out here is going to go into the collector of the transistor, which is the middle leg. So there we go. So the wire coming from the normally closed relay connection point is going to the middle leg of the transistor, the collector. After it passes through the transistor, it needs to go back to the battery. So I'll take that black wire, that original black wire that's connected to my batteries, and put that into the row that the furthest right leg of the transistor is on. That's the emitter. Next, to determine how open or closed the transistor is, we're going to connect to our Arduino with the base pin, but we don't want to go straight to it. We want to have it go through this resistor first. So here's my 1000 ohm resistor. One leg is in the same row as the furthest left leg of the transistor, and the other leg of the resistor is in an open row. I'll put in that last row a jumper wire that then goes over to pin 3 on my Arduino, or any of the other pulse wave modulated ones with the tilde or analog pins. We can just decide that in our code. So if any of those other ones are open, you could use them. One last wire that is often easy to forget is, of course, our ground. We have to make sure that the Arduino's ground and the battery ground agree. So I've got one extra wire. I'm going to put it in the same row as the emitter leg, furthest right leg of the transistor. and any of the grounds open on my Arduino. There's one right here. Cool. So that should work out nicely there. It's going to take some code to make it work. So if your car was working up to this point and you put this throttle in right now, next time you power on the Arduino, nothing's going to happen. The motors will not move because we haven't told it to open up this transistor at all. We're going to need to do that in the code. So let's switch back over and see if we can test this out real quick on our current code, see where we want to add this to accomplish that. It's going to be good here, instead of just using number 3 like we did in the example before here with our analog write, if we declare a variable at the top and assign it to 3. That way if we change the pin on our Arduino that we're using, we don't have to go find all the places that we wrote it in the code. We can just change it once at the top here. So I'm going to declare a new variable for that pin. I'll call it the throttle pin. And right now I have it plugged into 3, so we'll keep it there. All right, so here, just easiest thing that we can do right away is let's do our test routine again. So I'm going to delete this part of the code out of my setup where we were trying to make it do a left turn. Go back to the loop area, which repeats over and over again, and I'll uncomment this. Get it back. Because this part repeats, turning right, turning left, going forwards, going backwards, on and on and on. Because we made those modifications to our functions, this might look a little different if your code is slightly different. Since I have a full stop after everything, that's going to make sure that it's actually only doing one of these things at a time. So it will only turn left, will only turn right, etc. Let's, right here, use that analog write function, top of our loop. And set our throttle at about half its normal speed. So this is acting on the throttle pin, which just means 3 because we declared that variable at the top. And if we wanted about half the speed, we should pick a number somewhere between 0 and 255. So let's say about 120. That would be about half the speed. Let's plug this in, upload it, and see what it looks like. Check my port. Got to select that and upload. All right, switching back to the camera so you can see what we're hearing. All right, so it's a little bit more tired than it was with the full speed before. Let's drop this down even smaller. Let's see what 50 looks like. All right, so important thing to notice here is the turning, it doesn't seem to be turning at all. Back wheels are definitely going slower. So this is a important thing to notice on the way that we set up our throttle. Our throttle is the last stop that the current from both motors goes through before getting to the battery. So I've wired this in such a way that it controls the power or speed of both the steering and driving motor, which might cause some issues because you saw it didn't turn the wheels at all when we wanted that. So if we wanted to like sharply turn but move slowly forward, that might take a little bit more work to achieve. One solution would be to use 2 transistors instead of having this one that is for both of the output currents of the relays. I could have it be so that it only acts for 2 of the relays on one transistor and a different transistor for the other 2 relays. Then I could set the throttle differently for both of them. Hopefully this would be enough of a introduction that you could think through what you would need to unplug and change about your wires on the relay. in order to kind of duplicate this throttle part here over next to it in order to achieve that. But I leave that as a challenge for you.